Hello and welcome to Excel Mathematics TV. This presentation will be about properties. When we say properties, we are referring to the properties of operations such as addition, subtraction, multiplication, and division. Do you know any properties? In this lesson, we're going to talk about them. Let's start by learning the distributive property. Look at the word distributive. By analyzing its literal meaning, we can get an idea of what the distributive property is all about. The distributive property states that to find a product of a number and a sum, we need to multiply the number outside the parentheses by the addends inside the parentheses. It's just like we're distributing the number outside the parentheses to the expression inside the parentheses. That may have sounded a little confusing. If so, let's discuss it a little further. For example, to find the product of x times the quantity of y plus z, we need to multiply x and y. Then, we also need to multiply x and z. Just put the addition symbol in the middle. Thus, x times the quantity y plus z is also equal to the product of x and y plus the product of x and z. You see, we just distributed x to the addition inside the parentheses. That's why it's called the distributive property. Let's learn this property further by solving an actual example. We have 7 times the sum of 2 and 3. It looks easy, right? Let's go ahead and solve it. Of course, we are going to apply the distributive property. We will distribute 7 to the addition expression inside the parentheses, and have the product of 7 and 2 plus the product of 7 and 3. Let's now discuss how to solve an expression when the number or variable outside the parentheses comes after the parentheses. Will we get the same answer, or is the process the same? Let's find out. To find the product of the quantity of y plus z and x, we just need to multiply y and x, and then also multiply z and x. Then put the plus sign in between. Thus, the product of the quantity y plus z and x will become y times x plus z times x after applying the distributive property. Let's have an example. Let's apply the distributive property in the expression the product of the quantity 5 plus 6 and 9. I'm sure you know how to apply the distributive property. Applying the distributive property will result to 5 times 9 plus 6 times 9. Let me give you some tips. The answer doesn't change even if we put the number outside the parentheses on the other side. So we just learned how to use the distributive property. It will be a waste if we do not use that knowledge. So let's use the distributive property. Let's find the product using the distributive property in this next equation. First, we have 6 times 56. We can't work on this expression yet. First, we need to rewrite the expression using the distributive property. We will just express 56 as the sum of two numbers. 50 plus 6 will do just fine. Then enclose 50 plus 6 with a parentheses, and we have 6 times the quantity 50 plus 6. Now we can solve this expression using the distributive property. We will distribute 6 to 50 and to 6. And we have the product of 6 and 50 plus the product of 6 and 6. After that, perform the indicated operation. Multiplication first. 6 times 50 is 300, and 6 times 6 is 36. So now we have 300 plus 36. And there's only one thing left for us to do, and that is add. 300 plus 36 is 336. That means 6 times 56 is 336. Let's have 7 times 89 as the second example. We will use the same process as in the first. What should happen first? We're going to rewrite the expression. We will simply express 89 as the sum of two numbers, and the expression is now 7 times the sum of 80 and 9. We can now apply the distributive property in this expression. Doing so will result to 7 times 80 plus 7 times 9. We will do the multiplication first. 7 times 80 is 560, and 7 times 9 is 63. Put those two together and we have 623. Thus, 7 times 89 is equal to 623. So we already know how to use the distributive property. Let's now apply it in solving a worded problem. Here's the problem. There will be a freshman socialization day next Friday, and the treasurer will collect the class fee. Each student needs to pay $3.50 for their food and $2 for the shirt. How much does he need to collect for 30 students? As always, read the problem carefully and analyze it. You should know what is being asked. The problem is asking for the total class fee collected. So let's go ahead and find that. To find the total class fee collected, we need to find the total cost for each student. That means we will add what they paid for their food and shirt, then multiply the answer by 30, since it is the total number of students. So total class fee collection is equal to the total number of students times the sum of the cost of food per student and the cost of shirt per student. Let's substitute the actual values from the problem into the equation we made. The cost of food per student is $3.50, and the cost of shirt per student is $2. Substituting will give us 30 times the sum of $3.50 and 2. We can solve this expression by applying the distributive property. We just need to distribute 30 to the expression inside the parentheses and multiply it to each of the addends. Doing so will result to the product of 30 and $3.50 plus the product of 30 and $2. Now we can proceed to the multiplication. After multiplying, we have $105 plus $60, which is equal to $165 after adding. Thus, the treasurer needs to collect a total of $165 for the coming freshman socialization day. I think that's enough for the distributive property. Now let's study the properties of addition and multiplication. Let's start with the commutative property. The commutative property states that the order of numbers in addition or multiplication does not affect the sum or product. Now, what do we mean by that? It doesn't matter if you interchange the numbers. The answer is still the same. To have a better idea about what the commutative property is all about, let's explain using variables. If we have x plus y, we can also write it as y plus x, and the answer will not be affected. For example, 3 plus 6 is also equal to 6 plus 3. You see, we can interchange the numbers in addition. That's what the commutative property is all about. We can also apply the commutative property in multiplication. That is, if we have x times y, we can also write it as y times x. Say that we have 11 times 22. We will still get the same answer if we change the expression to 22 times 11. And that's one easy property. Let's move on to the next one. This one is the associative property. The associative property states that the grouping of numbers in addition or multiplication does not affect the sum or product. But keep in mind that this applies only if the operations in the expression are all the same. It's either they're all addition or they're all multiplication. Putting it to an equation, it means that the quantity x plus y plus z is equal to x plus the quantity y plus z. Let's have a concrete example. The sum of 5 and 4 plus 8 is the same as 5 plus the sum of 4 and 8. In multiplication, the product of x and y multiplied by z is the same as x multiplied by the product of y and z. A good example is the product of 2 and 5 multiplied by 3 is the same as 2 multiplied by the product of 5 and 3. We still have two properties to learn. Let's talk about the additive identity. When 0 is added to any number, the sum is always that number. That makes sense, right? Because we're basically adding nothing, so the result would be the number itself. If we add 0 to x, the answer is simply x. That sounds really easy, and so it's pretty easy to remember. Let's have an example. 9 plus 0 is 9. This is an example of additive identity, because the answer is the number itself when we added 0 to it. Moving forward, let's have the last property. This is also an identity property. Let's talk about the multiplicative identity. In the additive identity, we add 0 to a number and the result is the number itself. While in the multiplicative identity, 1 is multiplied to any number and the product is always that number. Putting it to equation, x times 1 is equal to x. Let's also have an example for this one. 3 times 1 is equal to 3. You can multiply any number by 1, and the answer is always that number, no matter how big or how small that number is. So we've learned all the properties in this lesson. It's now time to study how to identify properties. Let's test how much we know the properties that we've discussed by identifying the properties shown by each equation. First, we have the quantity 8 times 9 multiplied by 10 is equal to 8 multiplied by the quantity 9 times 10. Which property was applied here? As you can see, the way the numbers are grouped does not change the product, because if we're going to simplify the left and right side of the equation, the answer would be the same. Thus, the property shown is the associative property because we're dealing with grouping. That's a hint for you to remember. Let's move to the next equation. -10 plus 0 is equal to -10. 0 was added to -10 and the sum is still -10. This is one of the identity properties, and that is the additive identity. For the sixth example, we have 17 plus 13 is equal to 13 plus 17. This one's pretty easy. As you can see, we interchanged the places of the addends, but they still yielded the same answer. The order of the numbers does not change the sum. Thus, the property shown is the commutative property. Next, we have 25 times 1 equals 25. This is also one of the identity properties. 1 is multiplied to 25 and the product is 25. Thus, the property shown is the multiplicative identity. Properties are not just there for us to learn and store in our mind. We also need to apply that knowledge in some situations where it's appropriate to apply them and will make solving easier and faster. Let's use the properties to find the following expressions. We have 2 times 97 times 5. Notice that there are 3 factors and there is no other operation involved aside from multiplication. Now look at the expression again. Since it's easier to multiply 2 and 5, we will change the order and place 2 times 5 first. By the commutative property, we know that the change of order will not affect the change of product, so this action is fine. The expression is now 2 times 5 times 97. There are 3 factors involved, so we can group them for us to know which one to solve first. By the associative property, we can group the numbers however we like. Since we want to make solving easier and faster, we will group 2 times 5 and put that expression inside parentheses. 2 times 5 is 10, so the expression is now simplified to 10 times 97. Multiplying 10 and 97 is pretty easy. We just need to add 1 0 to 97, and that's the product. Then the answer is 970. Thus, 2 times 97 times 5 is equal to 970. Now we're down to our last example for the lesson. Let's solve 25 plus 88 plus 75. Look at the question. It's a lot easier to add 25 and 75, right? So what we're going to do is change the order by applying the commutative property. Doing so, our expression is now 25 plus 75 plus 88. We need to put together 25 and 75 by applying the associative property. After that, the expression becomes quantity 25 plus 75 plus 88. Now, it's a lot easier to solve. 25 plus 75 is 100, and we just need to put plus 88 to come up with the simplified expression. So, we have 100 plus 88, and those two add and get 188. Thus, 25 plus 88 plus 75 is equal to 188. Those are the properties. If you master them, it will make solving some math problems easier and faster, because that's where we apply that kind of knowledge. We can also apply it in real-life situations, though. Thank you, and we'll see you next time.